The Fatal Particle Collider. In 1985, Dr. Edward Lane activated a prototype particle accelerator in Los Alamos, unaware the machine's containment fields were dangerously unstable. He watched particles swirl inside the magnetic ring, the air shimmering with static energy that made papers flutter. The machine hummed louder, vibrating violently, heating the metallic lab with an unnatural intensity. Without warning, the containment field wavered, and the core released a concentrated burst of lethal radiation. Lane felt searing heat in his chest, numbness spreading from fingertips to torso, panic flooding his mind. Colleagues rushed to help, but the field locked him in place, room shaking violently around him. His body convulsed violently, muscles jerking uncontrollably under the intense electrical force. Sparks ignited small chemical containers, flames licking the walls of the metallic lab. His vision blurred as radiation fried nerves, leaving him disoriented and panicked. The particle core surged again, sending Lane backward into a wall, fracturing bones instantly. Smoke and sparks filled the room, making it impossible for rescuers to approach safely. Each pulse of the machine intensified the convulsions, twisting his limbs into grotesque shapes. His colleagues screamed, but the protective glass panels shattered, exposing everyone to minor shocks. Lane's skin blistered where energy exited his body, forming grotesque blackened patches. A final surge ripped through his body, freezing his limbs in an unnatural spasm before collapse. When rescuers arrived, only smoldering equipment and scattered chemicals remained. The particle accelerator that promised breakthroughs had claimed its first human victim. Dr. Edward Lane became a stark reminder of the invisible dangers lurking in cutting-edge science. Incident 2. In 1996, chemist Karen Wetterhahn carefully handled dimethyl mercury at Dartmouth College, unaware that even a drop could be fatal. She wore latex gloves and followed all standard procedures, confident in her years of experience. A single drop accidentally touched her glove, a minuscule intrusion she immediately cleaned, thinking she was safe. Unseen by her, the mercury penetrated the glove and began silently entering her bloodstream. Months passed without incident. Wetterhahn taught classes and conducted research, completely unaware of the poison within. By January, she began slurring words and losing balance, a creeping paralysis unnoticed at first. Within weeks, her motor control deteriorated further. Walking, speaking, and writing became impossible. Vision blurred and hearing dulled as mercury attacked her nervous system, slowly dismantling it. Doctors discovered extensive neuron damage. The toxin had crossed her blood-brain barrier months earlier. Her muscles no longer responded to commands, rendering her completely immobile. Speech became impossible. She could no longer communicate with family or colleagues. Karen slipped into a coma as mercury continued silently destroying connections in her brain. Medical staff could do nothing. The poison had been accumulating invisibly for months. Her body remained alive only through machines as the nervous system collapsed completely. By June 8, 1997, 10 months after the initial drop, Karen Wetterhahn died quietly in her hospital bed. The very toxin she had studied her entire life had claimed her, invisible and silent. No dramatic explosion, no sudden trauma, just a slow, invisible annihilation from within. Karen Wetterhahn's death became a chilling reminder that the smallest exposure can have the deadliest consequences. Incident 3. In August 1753, physicist Georg Wilhelm Richmond sought to replicate Benjamin Franklin's electrical experiments at his home in St. Petersburg. He constructed an elaborate apparatus with a metal rod connected to a suspended iron bar inside his study. Dark clouds gathered as Richmond prepared for the storm, tension visible in his wide eyes. Thunder rumbled ominously, echoing through the streets, while Richmond's assistant observed quietly. The apparatus had no grounding wire. All electrical energy would flow directly into the lab. Richmond stepped forward to take a measurement as the air hummed with static electricity. Suddenly, a pale blue sphere of ball lightning materialized near the iron bar. The globe struck Richmond squarely in the forehead with incredible force. The electrical discharge tore through his skull, sending violent spasms through his body. He was thrown backward, knocked unconscious instantly, a small red mark forming on his forehead. His assistant watched in horror as Richmond remained motionless on the floor. Smoke rose from his clothing, and the iron bar above was twisted and partially melted from the surge. There was no pulse, no breathing. The lightning had stopped his heart instantly. The room smelled of scorched metal and burnt wood, a silent testament to the immense electrical energy released. Richmond became the first recorded person to die while conducting electrical experiments. The ball lightning had traveled from sky to rod to bar directly into his brain in less than a second. Scientists would later study his death, shocked by the raw power of uncontrolled electricity. Richmond's fatal curiosity became a grim reminder of nature's unpredictable fury. Incident 4. In 1944, inventor Thomas Midgley Jr., paralyzed by polio, built an elaborate system of ropes and pulleys to lift himself from bed. He designed it to regain independence, carefully testing each line for smooth motion. The system ran through multiple fixed points, a web of mechanical complexity. On the morning of November 2nd, he began his usual routine, unaware danger lurked. Suddenly, one rope twisted around his neck as the pulleys shifted. He tried to reverse the motion, but the mechanical advantage worked against him. Each movement cinched the cords further, constricting his throat and chest. His weakened arms lacked strength to free himself from the web of pulleys. Breathing became impossible as the ropes squeezed his airway. He struggled in vain, the system turning from aid to deadly trap. No one was nearby to hear or help, silence filling the room. Hours later, he was discovered suspended, lifeless amidst his own invention. The device meant to restore freedom had become the instrument of death. The tragedy highlighted the cruel irony of ingenuity misapplied. His death shocked the scientific community, a grim warning of hubris and over-engineering. Midgley's own creation had outsmarted him in the deadliest way possible. The bedroom became a silent memorial to ambition turned fatal. Thomas Midgley Jr. died alone, strangled by the very invention designed to liberate him. Incident 5. In 1900, Dr. Jesse Lazier deliberately allowed a yellow fever-infected mosquito to bite him in Cuba. He recorded the bite in his notes, confident in his experimental proof. Days passed, and he initially felt no symptoms, unaware of the brewing infection. On September 18th, 5 days after the bite, he developed a fever and headache. His muscles ached with increasing intensity, signals of internal chaos. By the second day, his eyes and skin turned yellow as jaundice set in. Vomiting began, first clear, then dark and almost black, a horrifying sign. Internal hemorrhaging continued, leaving him weakened and disoriented. Kidneys and other organs began to fail, his body betraying him completely. Delirium overtook him as his brain swelled from infection. Medical staff could only try to keep him comfortable as the virus ravaged every organ. His breathing grew labored, heartbeat erratic, clotting impossible. 7 days after symptoms appeared, Lazier's body gave out completely. The self-experiment that sought proof of transmission had become lethal. His final moments were a stark testament to scientific bravery and its dangers. Lazier's body succumbed to the exact disease he had exposed himself to intentionally. The bite that was meant to prove theory had claimed his life. Jesse Lazier died as he had predicted, the ultimate consequence of deliberate exposure. Incident 6. In 1896, chemist Vera Papeva attempted to synthesize the unstable compound methylenophosphane in her lab in Russia. The compound was predicted to ignite spontaneously when exposed to air. She worked using sealed glassware and an inert atmosphere, fully aware of the risks. Every step required precise temperature and pressure control. As she prepared to isolate the product, a seal failed. The slightest trace of oxygen contacted the compound. In an instant, the methylenophosphane detonated violently. Glass shards became flying projectiles, piercing arms and torso. The chemical fire spread rapidly, igniting nearby materials. Smoke filled the room, obscuring the devastation. Other researchers arrived too late to help. By the time they reached her, the damage was fatal. Shrapnel had penetrated her chest and abdomen. Burns covered her arms and face where the fireball had reached. The combination of trauma and fire proved lethal. Vera Papeva became one of the first female chemists to die in pursuit of experimental chemistry. The explosive synthesis ended her life, a stark reminder of chemistry's hidden dangers. Her work succeeded for only a fleeting moment before destroying everything around it.